I'm just going to have a look at this one. And in the break, I'm going to want you to write down the steps, see how you go. So I'm not going to go step by step through the chi-squared test because, as you saw on that document, it's very complex. So what we did is we asked the students, how useful do you think MSci 110 quant methods of business will be in your future career? And we also asked you, how successful have you been in the past of mathematics? And we're interested to know if there's a relationship between the two things in the population, and we're using a sample of students to represent the whole class. Why might there be? Just because when we do questions, we're not just doing them because, I've got to think up a question. Do you think that how successful people have been in the past might influence how useful they think this course will be? Does that make sense that somebody might do that? But then again, it sort of does, because people who are better at maths think maths is worthwhile. But the other thing is that maybe people who are mystified by maths think, it must be really important because I can't do it. So there's a reason why it might not be the case as well. And so this is what we want to see. Is there a case to say that there is a relationship between them? Okay, so there you are. I'll give you a minute or two. See if you can write down the null hypothesis and all of that sort of stuff. I don't think you can do all of it, but you can do some. Right, we'll start off with our null hypothesis. So it's that there is no relationship. Now, this is something I'm expecting you to be able to write in the proctored quiz. So pretty much memorise this. There's no relationship between, and then whatever the two things are. So in this case, it'll be perception of the usefulness of the course and how successful. It's sort of funny having my hands exposed like this. I keep thinking, make sure my nails are good. How successful students. Because in OHPs you only get the shadow, you don't get the hands as well. Now you'll be looking at them. I should have kept quiet, shouldn't I? Okay, so the alternative hypothesis is exactly the same, except one word changes. What word are we going to change? No, that's right. So same sentence, except, in fact, I've got it wrong here. So hopefully I think I fixed it on the stuff you print off at the end of this lecture, but if not, and you're watching this on the video, it should say there is a. So there is a relationship, blah, blah, blah. So exactly the same, but in one case you say no, there is no relationship, and the other one there is a relationship. Okay, what should we choose for our level of significance? I know, let's go for 0.05. Okay, and then collect the data. So we asked 60 students, blah, blah, blah. Okay, 60 or 50? 60. Okay. Oh, sorry, from the class, the two questions. I haven't got enough room to write it all out, so it's the two questions on the previous page. Okay, so now I'm going to talk about how to calculate the p-value. And I'm going to go quietly through it. Okay, so this is what your data looks like. Now, last year, when it was taught differently, they actually gave you the table. But one of the problems with that is that people don't actually get an idea of where the table comes from. And this is how you see that this is nominal data. So this is what it looks like. Those spreadsheets you sent in, I collected them all together, transposed them, and this sort of stuff, and this is what we got. So if you put very successful, very useful and successful, that could be you. We don't know, because it's all anonymous. So I've got my column down here of very useful, blah, 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 and then this one successful, not really successful, and so on. I've actually taken out a couple of categories because they were too few. And one of the things with chi-squared is that if you have too few in any category in the tests, it's a little bit beyond the level of this course. All I want you to do here is to know how to do the basics. Okay, so what we want to do is have a table that tells us how many people said it was useful and not really successful. So if you're going to do this by hand, you would have to go through, okay, very useful and successful. Okay, that's that one there. Okay, very useful and successful. Yep. Useful and successful. Yep. Very useful, not really. Okay, very useful, not really. Okay, useful, not really. Useful, not really. And so on. So that's if you're going to do it by hand. And in the days before computers, which I remember very well, that is how you did it, basically. So a lot of statistics analysis that is done these days just wasn't done because who the heck wants to do that for 1,000 thingies? So we don't have to do that. Instead, we have this thing called the pivot table. Now, the pivot table has got to be one of the ugliest pieces of programming I have ever seen in my life, and it is so counterintuitive as to make you want to run away. But I have simplified it for you, and all you have to do is this, and it shouldn't be a problem. Okay, so you use your pivot table to get there. Okay, so you go to data, and then pivot table, pivot chart report, this one here. And then you go down and you do this step, and then you have this step, and then you get to this step, and so on. And so you want it to look like this. So we're interested in success and usefulness, so we drag usefulness to here. So that's literally what you do. It comes like this, and you drag that to there, and it doesn't actually matter which one you put in the middle. So I don't know why, but it doesn't. Okay, you can actually have a third variable in there if you wanted and have the mean of it or something like that. I've never quite got pivot tables, as you can probably tell. But you drag that one into there, and it automatically goes to count. So this is what it should look like. Okay, and then don't go help because it really doesn't. And you go OK. So you go OK, and it does this magical thing, and it produces this thing here called a pivot table, which, when you know how to do them, are enormously versatile and fabulous. And Jennifer Brown from Stats Department just thinks everybody should know how to do them. But the problem with pivot tables, it's hard to do more than just a little bit, really. Okay, so how it works is it's got this table, and you don't actually worry about the other bit. And if it goes funny, just delete and start again, because it's really hard to make it not funny after it's gone funny. Okay, so what we want to do is you want to highlight this and copy it, because this is observed, and this one here is we want expected. Yeah, let's turn my page over. All right. Now, the way you do it is you copy that. By the way, if you try to highlight from up there, it doesn't work. So highlight from the bottom corner. It works way better. So just highlight this bit here, and then copy, and you do a paste special. You don't want to paste this because it comes really weird. You want to do a paste special, and it's values only. Special values. It's all in the handout, okay? So then we get this thing here which has the same numbers in it to start with, and we clean out these ones here and make them empty, and then we use the same formulas we used before. We use this formula here and put it in there. Now, I've explained step by step how to do that, but one of the best ways to do it is you do your formula for here, make sure you've got your absolute references right, and then just copy it through to the others, and then you can just check to make sure it's okay later. So take it off the handout, and I'll show you how to go about it. So then we just do this one here, which is the equals chi test, and then it would have our expected values, which are, I can't even remember which order it goes in. Whichever order it goes in, it will refer to this lot here, and it will refer to this lot here, but not the totals, just the bits in the middle. But you'll get practice doing this in the non-proctored quizzes.